In this video, we're going to practice taking the derivatives of some complicated logarithmic functions. But to begin, let's just go over the derivative rules of logs of x. Now, the classic base that most mathematicians are going to work in is going to be base e. E is the natural number, and so that's why the logarithmic function with base e is called the ln. You could read this as ln, but I'll commonly refer to this as just log. The reason the n is there is because e is the natural number, and natural starts with n. The derivative of ln of x is just 1 over x. Now, if you're working in any other base besides the natural base e, the derivative of the log base a for any real number a greater than 1 of x is going to be 1 over x times the constant 1 over the natural log of a. Keep in mind that the natural log is in base e. So, if my letter a is equal to the base e, then the natural log of e is going to be 1. Then I'll have a 1 over 1 here, and that's how I get to this formula right here. That's why we prefer to work in the base e. Right here, the ln represents base e. It's because we don't have any pesky constants that pop out of the derivative. Okay? Sometimes the second most common base to work in is base 10. So sometimes if you have to work in another base, your derivative is still going to involve the functional form 1 over x. However, there's going to be this pesky constant, and here I've written that note that 1 over ln of a is just a constant. It's just going to be a multiplicative number. And so you're just going to have to deal with that because you didn't want to work in base e. Okay? So usually we're going to be working with the natural log. Alright, so those are the two rules that you need to know. And you should also recall the properties of logarithms that you learned in Math 147. So I've laid out the three most important ones right here. The log, whether it's the natural log or the log of any other base, it doesn't matter. The log of the product a times b is equal to the sum of the logs. Okay, so if you have a product a times b and you're taking the log of that, you can turn that into the log of a plus the log of b. If you have a quotient a divided by b instead of a product, then that's going to break up as the log of a minus the log of b. Does that sound familiar from last quarter? Hopefully. And then finally, our last property is that if we have the log of base a raised to the b, so here this one, the b is in the exponent, then that b is going to pop out into the front, and that's going to be equal to b times the natural log of a. You definitely want to keep these log rules in mind as you work through any and all problems involving the logarithm, because those may help you to simplify the problem. Okay, so let's start with some simple examples, and for these I have to have you note that we will usually need the chain rule. Okay, that's because the chain rule is used on compositions of functions. So that's used on compositions. And usually the derivatives that we're going to take are going to be compositions because log here is the outside function, but then the inside function is the thing that I'm taking the log of. Now keep in mind our original rule is that the d dx of log x is 1 over x. So if I ask you what's the derivative of log x, the answer is just 1 over x. Usually I'll be asking you what's the derivative of the log of something beyond x. And that's going to make it a composition of functions, and that's going to make us use the chain rule. The chain rule is the most common rule that we're going to use when we're taking the derivative of logarithms and of exponentials. Okay, so keeping that in mind, let's try to take the derivative of the log of 3x. The inside function is 3x, and the outside function is the log. Okay, so you want to keep that in mind. The inside function is 3x. And then the outside function here is the ln. That's the outside function. Do you guys remember what the chain rule is? When you're taking the derivative of a composition, you take the derivative of the outside function, evaluated at the inside function, and then you multiply it by the derivative of the inside function. Okay? So that's what we're going to do here. So we recognize the inside function is 3x. The outside function is the ln. And now to take the derivative of this, so here I'm going to take the derivative with a prime. I have to take the derivative of the outside function and leave the inside function alone. Okay? So let's just pretend to have log of stuff. Now the derivative of log of x is 1 over x. So the derivative of log of this stuff is going to be 1 over that stuff. See, I have to put whatever was inside the log, I have to put it underneath the fraction. Okay, but that's not the end. Then, according to the chain rule, I must also multiply this by the derivative of the inside function. Now that's the part that people are going to most commonly forget, so please try to keep that in mind. What is the derivative of 3x? Just 3, right, it's just 3. And so, the actual derivative of ln of 3x is going to be 1 over 3x multiplied by 3, because that's the derivative of 3x, and that simplifies down to simply 1 over x, because the 3's cancel. Hey, does that seem a little weird? Because I had a 3x in here, and yet the actual derivative doesn't even involve the number 3? It's actually not that weird. Here's another way that we can see it using this log rule right here. Okay? Because actually not only is 3x the inside function, 3 times x is also a product. It's 3 times x, right? So there's an alternative way we could go. So I'll just write that in a different color. An alternative way that we could go is that we could see ln of 3x as the log of a product. And so that means it's equal to the sum of the two logs. So it's equal to log of 3x is equal to log of 3 plus log of x. Okay, I haven't taken the derivative yet. I'm just saying that it simplifies like that because we have this log rule right here. Okay? So if I want to simplify it first, that might make the derivative easier to take, because if I want to take the derivative of this, that's the same as taking the derivative of this sum. And so all I have to do is say, what's the derivative of log of 3, and what's the derivative of log of x? Now, the derivative of log of x, that's right there. That's 1 over x, right? So that's going to be 1 over x. But what's the derivative of log of 3? You got to be careful here. This is a common mistake that I see in class. Some people are going to say the derivative of log of 3 is 1 over 3. Did you say that? Were you thinking that? It's actually not true. The derivative of log of 3 is equal to 0. Okay? So watch out there. The d dx of log of 3 is equal to 0. Why is that? Because the derivative of a constant is equal to 0, right? And log of 3 is actually just a number. Like if you took out your calculator and asked your calculator, what's the natural log of 3? It's going to give you some decimal approximation. And if I ever ask you to take the derivative of a number, the derivative of a constant number just goes to 0. So even if that number is represented in exact form as a logarithm of 3, keep in mind, that's just a constant, and it will derive down to 0. So once again, we just get the answer 1 over x, and that matches the 1 over x that we got above there. Okay? So either way you go, you should get the same answer. But I'll tell you, depending on which track you take here, there's a couple common mistakes to look out for. If you're going to go this way right here, the most common mistake I see is that people forget the 3 that comes from the chain rule. The most common mistake right here, if you go this way, is that people will mistakenly take the derivative of ln 3 as 1 over 3, which it is not. The derivative of ln 3 is 0 because ln 3 is just a constant. Okay? So watch out for those pitfalls depending on the way you go, and keep in mind there can be many ways to get an answer sometimes, but the answer should always match as long as you haven't made any mistakes along your path. Okay, so that was a great first example. Now let's check out this second example here, which is only slightly different. Instead of the log of 3x, I'm asking you to take the derivative of the log of 3x plus 1. Now the reason this one changes it is because you can no longer see the inside function here. You cannot see this as a product because it's not just like 3 times x, it's 3x plus 1. Okay, so this one is not necessarily a product on the inside so much as this one can clearly be seen as the product of 3 times x. For that reason, I will not choose to go this alternative route with this problem right here. I'm going to have to choose the original route that I did up here, which used the chain rule. So why don't you go ahead and try that yourself? Definitely want you to play along here. Try to take the derivative of the log of the quantity 3x plus 1. Okay, let's see what you got. Now once again, we're going to treat this stuff right here as the inside function. So we're going to see 3x plus 1 as an inside function. The outside function is log. And so the derivative of the log of stuff is equal to 1 over whatever that stuff was on the inside. And then don't forget, what are you supposed to not forget? Multiply this by the derivative of 3x plus 1, which is equal to 3, right? So the answer here is 3 over 3x plus 1. Notice how that's different than what happened up here. Up here it was very convenient that the two 3's could cancel out. And that's the same convenience that's seeing the log of 3 split off from the product. Right? Over here in this case we could not have that happen. And likewise you cannot cancel this 3 with that 3 because you have 3x plus 1 on the bottom there. So this is in its simplified form and that's the answer right there. Okay, now let me address this one right here, the fact that if I'm in a different base, I'm going to get a similar derivative as to what I would get in base E, but there's going to be the constant 1 over log A that pops out. Okay, so now I'm going to redo each one of these problems, but I'm going to use a different base. Let's use base 10 because that's the most common base that people use besides base E. Okay, so I'll do this in blue here. Let's say instead I wanted you to take the derivative of log base 10 of 3x. The only difference between this and working in base E is that you're going to get the same exact answer you got before. So I showed you two different ways that this answer is equal to 1 over x. And there's going to be a multiplicative constant which involves what base you are working on. So the answer to this one right here is going to be 1 over the natural log of 10 times 1 over x. Okay, otherwise it's going to be the same exact answer. Likewise down here, let's say maybe another base. Let's try log base 7. If I was in the log base 7 and I wanted to take the derivative of 3x plus 1, once again I'm going to get the same exact answer that I got before. So it's going to be very similar to this right here, which is 3 over 3x plus 1. But there's going to be a multiplicative constant in front of the derivative that I got, and that's going to be 1 over the natural log of the base that I was working in. Okay, so keep in mind that this part right here is just a constant. Go ahead and ask your calculator, what's 1 divided by the natural log of 7? There's just a decimal answer for that. And then otherwise, it's multiplied by the same exact answer that I would get out of doing the problem in base E. Okay, so for the remainder of these problems, I'm just going to work in the natural log base E. But you can see that if you choose any other base, you're just going to get this one constant multiple that pops out right there. Okay, so let's get into some more complicated examples here. And as we go through these examples, we will try to think of any ways that we could simplify using those log rules before we take the derivative. Okay, so some further examples here. Let's say example C, what is the derivative of log cubed? Try to take that one. Or in D, what is the derivative of 2x squared plus x? Try to take that derivative right there. Okay, definitely want you to try these on your own. That way, even if you don't get it right, you'll have something to match up with the correct answer, and that way you can troubleshoot and you can pinpoint your own mistakes. So, before I do the answers, please pause the video and try these out by yourself. Okay, have you been playing along? Now there's two ways you can do this one. Up here, you can either simplify it using this log rule right here, maybe that's the way you went, or you can just do it straight away, seeing x cubed as the inside function and log of x as the outside function. Okay, so let's do it that latter way first. If I see x cubed as the inside function, the derivative of the log of that is going to be just 1 over that inside stuff. But don't forget the chain rule. The chain rule has to be enacted almost every time on questions such as these. So what's the derivative of 3x x cubed is 3x squared is the derivative of x cubed. And so what happens is this x squared cancels with the cube of that. And so the answer that we get finally, simplifying, is just 3 over x. Did you get that one? Maybe you went the other way. So the alternative route I can use is I'm going to use the log rules to simplify first and then take the derivative. Okay, so keep in mind when you're doing that, you are actually simplifying the function first. For this one, we would take the 3 and it will pop out. And then we can take the derivative. And when it's time to take the derivative of this, we're trying to take the derivative of that, the 3 is just a constant multiple. So that part just stays on the outside. And the derivative of log x is 1 over x. And so, lo and behold, I get the same answer, 3 over x, that I got before. So either way, you should get the same answer. And it's kind of fun to do it both ways because then you can see them match up, right? Okay, so similarly, there's actually 2 different ways to get this answer. What you can do is you can just go ahead and do the chain rule. Or you can split this up into a product where you factor out an x, and then you could take the derivatives. I think either way you go, you're going to end up using the chain rule on this one, so you might just prefer to go ahead and do the chain rule straight away. Did you try it? Okay, so let's see what you got there. So if we just do this one straight away, the derivative of the log is going to be 1 divided by the stuff that was inside the log. Don't forget the chain rule. Then we have to multiply by the derivative of the inside stuff, which is just like that. And so what we get is 4x plus 1 divided by 2x squared plus x. I don't see any like terms that can really cancel on the top or bottom. And so that is what I'm going to box as my final answer. Okay? But let's see the alternative way. In this case, I think the alternative way might have ended up as a little more work for you, because it starts like this, where you take an x and you factor it out. So you have simplified it, some would say unsimplified it, as the log of the product x times 2x plus 1. If you choose to go this way, then what you would want to do is break this up into the sum of log x and log of the quantity 2x plus 1. Okay, notice that I have not taken the derivative yet. All I'm doing on this line right here is I'm enacting the log rules that I should know by heart, and in the hopes of sometimes make it simpler, like maybe you thought that way was simpler. In any case, now I'm going to take the derivative term by term. So the derivative of log x is 1 over x. The derivative of log of 2x plus 1 is 1 over 2x plus 1, and don't forget to multiply that by 2 due to the chain rule. You see how I needed the chain rule anyway? Always keep the chain rule in mind when you're taking derivatives of logs. So anyway, in conclusion, I get 1 over x plus 2 over 2x plus 1. And if you went this way and you're trying to match it with the other way, does it seem like those are the same thing? Maybe not at first, but if you actually took these fractions and you combined them, so you put them over a common denominator by cross-multiplying, then you would see that this is actually equal to 2x plus 1 over x times 2x plus 1 plus 2 over 2x over x times 2x plus 1. And then if you cross-multiply to make the common denominator, and then you combine the numerator, then you're going to see 2x plus 2x is 4x plus 1, 4x plus 1 divided by the same common denominator, but we just see that denominator in factored form in the red solution. So it actually is the same thing, it's just 2 different ways to get the same thing. Okay, so I just have a couple more examples, and these are going to be my most complicated examples. Now, sometimes you will have to occasionally use another rule, like the product rule or the quotient rule, if you cannot escape the fact that you have a product or a quotient. But those will not nearly be as common as using the chain rule. You need to use a chain rule on practically every problem here. Okay, so for this problem right here, you see that I have the log of a product. I have the log of x to the 4 times the square root of 4 minus x. Am I going to need to use the product rule in there? Well, I would if I didn't escape it by possibly simplifying the log of a product into the sum of the logs. So you might want to take that and simplify it like that, and you might want to also consider the fact that x is raised to a power here. 4 minus x is raised to a fractional power right there, and you can also use this rule to simplify. Try that way first. Okay, and then we have one more problem right here. Let's say we have the log of the quantity 7x divided by 2x. Now this one is a quotient. This is the log of 7x divided by the function 2x, and this is not something that I can really get away with by simplifying it out. This is going to be a quotient. So for this one right here, we actually need the quotient rule. So I'll give you the quotient rule again. We need this rule that says that f over g prime is equal to f prime g minus g prime f divided by g squared. Okay? This one, you can't escape it. It's a quotient. This one, it looks like a product inside, but I would say that you should try to use the log rules on this one first, this one E, and simplify that away so that you don't actually need to use the product rule. Okay, try them yourself first, please. And now I'll give you the answers. Alright, so how did you simplify this out? This is x to the 4 times the square root of 4 minus x. So, because that's a product of two things, I'm going to split that up into the sum of the logs of those two things. That's my first step, and that uses this log rule right here. Now my second step is, before I take the derivative of each term, I would also consider if I can use this rule to bring out any exponents. Like for example, on this one right here, that's 4 times the log of x. On this one right here, it might be a little hard to see at first, but what you should do is realize that 4 minus x squared rooted is the same thing as 4 minus x to the 1/2. Did you see that? And so that really is an exponent. It's just a fractional exponent. So then the 1/2 can come out like this, and then I'll have the log of the quantity 4 minus x. This is the form in which I highly recommend you take the derivative. If instead you started just with the chain rule and said the answer is going to be 1 over all this stuff times the derivative of all this stuff, when you take that derivative you would have to use the product rule. That way it would take longer, okay? So take advantage of the log rules if you can, and be careful not to overuse them in a case that you can't use them. But this is correct right here. And now it's time to take the derivative, right? I have not even taken the derivative yet, so please note that I haven't. I was just simplifying. Now I'm going to take the d dx. Okay? So the d dx of that function is 4 times the derivative of log x, so that's 4 divided by x right there. And then this one right here is going to be 1/2 times the derivative of this, which is going to be 1 over 4 minus x. And then don't forget the chain rule. What am I missing right here? What's the derivative of 4 minus x? Minus 1. That's right. It's the coefficient on that linear function, the coefficient of the x. So there's a minus 1 right there. So really the d dx is 4 over x minus 1 over 2, 4 minus x. Okay? So there I just brought the minus 1 to turn into a minus right there. And the 1/2 I kind of just pushed it in with that function right there. And that's the answer to that problem right there. If you want to go the other route, go ahead and do it. You'd have to use the chain rule, and then you'd have to use the product rule inside of that, and then you'd have to kind of cancel, use a lot of algebra to move things around, and you should end up with the same answer. Okay, I'm not going to do that on the board. I'm going to go to F now, and remember for this one, I cannot escape the fact that this is in a quotient rule situation. Now, be careful. When people start working with logs and they remember the log rules, they might have a tendency to overuse the log rules. So sometimes if people see a log function divided by this, they might, just by mistake, say, oh, this is just log 7x minus log 2x or something. That's not correct. I'm trying to show you a mistake right now because they would mistakenly see this as the log of all of that stuff. Okay? So that's not the way to go, and I'm just warning you, don't overuse the log rules because you get excited because they're so great, right? So just use them when they're appropriate. Okay, so we needed the quotient rule here, and so we're going to see the top as f and the bottom as g. And then we're going to go ahead and take the d dx. So we're going to take the derivative, take the d dx. And it says the derivative of the top function. Okay, so what's the derivative of log of 7x? Kind of like our first example, example A, the derivative of log of 7x is going to be 1 over 7x, but times 7. So really, the derivative of log of 7x is just 1 over x. That's right, the derivative of log of 7x is just 1 over x. The derivative of any number, of log of any number times x, it just goes down to 1 over x because the number just cancels itself on top and bottom. Okay, so that's the f prime, and then the g is 2x, so I'm going to put a 2x right there. And then I'm going to minus g prime, so the derivative of 2x is just 2. And then I'm going to multiply that by f, so I'm just going to leave that log of 7x alone right there. And then I'm going to divide the whole entire thing by g squared. Oh, be really careful right here. On the denominator, I have to square the entire denominator. Okay, so when I say be careful here, what I mean is don't write right here, this is another common mistake, don't write 2x squared. You see the difference between that? This function right here is the quantity 2x squared, so you either write 2x squared or you can write equivalently 4 times x squared. But it's not 2 and then you just square the x. You see the mistake there? So I want to make sure that you guys don't do that on the bottom. You're going to be dividing by the quantity 2x squared, which is equivalent to 4x squared on the bottom. Okay, so if I had to simplify this, then I would probably just write the 4x squared there. And then this x cancels with this x. So what happens on the top is that that whole term right there just turns into 1 over x, 2 over x. So that's just going to be a 2 right there. So then I have 2 minus 2 times log of 7x, and then I can see another thing that's going to cancel. There's 2 2's up here, and there's a 4 right there. So really, the simplified form of it is that that 2 cancels, that 2 cancels, and the 4 on the bottom becomes a 2. So I have 1 minus log of 7x divided by 2 times x squared. Okay? So hopefully you saw that. Rewind the video if you didn't get to see the unsimplified next to the simplified there. The reason that there's a 2 here instead of a 4 is because there's a common factor of 2 right here, and that canceled out. Okay, so go ahead and practice with those again and the ones on the homework.